like. It's just different topics in the Android SDK. So just a few announcements. Obviously, Project 2 is due March 3rd. That's 2 weeks from now. So you want to get that started ASAP. There was a few of you that waited till the last minute for Project 1, and you realized it was a little bit trickier than you probably thought initially. So don't forget to handle rotation. So I showed you how to do that in the camera example. Bob had a error. I fixed the error, pushed the fix up there. Yep, thank you for pointing that out. And I actually so for those of you who haven't checked Piazza yet, essentially when the activity was destroyed and we were pulling that file URI back out of the bundle that was saved before the activity was destroyed, we pulled it back out, but it was never saved, so it was null, and therefore it was trying to create a file from a null object and threw an exception. So I did a check for null just before doing the assignment. But anyway, that's what it is. So you can check out the example code for the camera and how that rotates and saves the file image URI. And if you don't know what I'm talking about, just go ahead and check that out and look at it there. You don't have to handle persistence in Project 2. So for example, the pins that the user adds, so these are user-added pins, obviously, not the JSON pins that you create from the web service. You don't have to persist that, and what that means, you don't have to persist it between application launches. So once the application goes away, it essentially resets everything. We will do that in Project 3, however. So if you want to work in a basic persistence mechanism in there, or a placeholder for future, then go for it, because again, that's going to be Project 3. And then there's no need to display the actual image. So you're going to take an image from the camera, you're going to display it in that details activity to add that pin, or you can call it a add pin activity if you want, whatever you're going to call it. You do not need to save that image anywhere, just display it, and that's good enough, and then create the pin. The pin does need to save the GPS location, the name, and the description, of course. So, any questions on Project 2 before we start? Okay, start on it this weekend.
I actually do have a quick question. I was
Okay.
Just kind of starting working through adding the map onto a new, project.
Okay.
And so it was talking about needing to install Google Play services, which I know you went through on I was watching one of your videos, and I'm just having a hard time actually getting Google Play services to install on the.
Okay, so when are you creating a Android virtual device, AVD, or a Genymotion
I have
emulator?
a Genymotion.
Okay, so on Genymotion there is a thread in Piazza.
Okay.
So log into that. Who posted that, by the way? I forget. Oh yeah, thanks, Nick. Nick
Sorry,
did.
I guess I haven't. Okay.
Yeah, so Nick has it all figured out, and actually a link that you can figure that out. So
Okay.
I recommend that. If you're using the AVDs, that those just work as long as you created an AVD with the Google Play Services image, and there's a bunch of images in there. I think the video up on the YouTube channel, the first tutorial video has how to create an AVD with the Google Play Services. So for whatever reason, if Genymotion is not working out for you, you can always use that. But that's a good question. Having said all that, it's always best to test on a device. Obviously, not everybody has a device, an actual physical device. Borrow somebody's if you want, but obviously not a requirement for this class. It just gives you 3 options to test your application. So hopefully, out of those 3, you can figure one of those out. But yeah, sometimes even in class, I can't get something to work. I'll switch over to another one, and I can't put it on the device because you can't see. Even though I do have this overhead projector-ish thing right here, it's an overhead with a camera, which is kind of futuristic for me. But anyway, okay, that's a good question. Anything else? Okay, so. The libraries that we have here are some to help you. Again, I keep listing, I think this is the 3rd set of slides I've listed out. OK HTTP, Retrofit, and Google's Volley for doing web service requests. My preference at the moment is Google's Volley, so if you can't make up your mind because you don't know which one's better or you don't have enough experience in either Java or Android to know, that's just my personal preference is Volley. It's done in the Android way. Retrofit's kind of done as a, I think, well, as a retrofit. They tried to retrofit your Android app for, I think it was originally like a Java-based application framework, and then they ported it over to Android in order to, well, no, I don't know what I'm talking about. But it does have to do with retrofitting your application with the web services API stuff. So that's the idea. I can't speak to exactly what it does. And then OKHTTP is pretty cool too. But the one at the top, Unity Events, if anybody's ever heard of the Unity game engine, it's at unity3d.com. This is just a, when I was doing these slides, I think I did these last semester or last year, I was also going through a bunch of Unity tutorials, and I stumbled upon this one. And what this is a video talking about broadcast events or the observer pattern. And so Unity is programmed in, well, one of the languages is C#. So this is a C# example. But if you're still struggling with the observer pattern, I highly recommend looking at this video because it does illustrate the code and everything of how two objects can communicate. We'll cover that a little bit today. So I've talked about, I have slides on auto, the event bus, or the observer pattern called auto. Today's slides will talk about the broadcast intents, which kind of accomplish the same thing. I did list those in last slides, but I said don't use them, and I'll show you why. But I'll show you the code, how that works, and everything. They do use intents, so it's kind of cool, but it's not like launching activities types of intents, which is explicit intents. And then finally, for our BSU maps example, I will show you Event Bus by Green Robot, and that's what I prefer for my observer pattern implementation libraries. But yeah, go ahead and check out this video if you're interested in the observer pattern and still struggling with that. It has very little to do with the actual game engine, though if you are interested in the game engine, it is free. Go ahead, download it. We'll talk about it later in class because you can make mobile games with it. Okay, so enough of that. The final one in this list is Garrett code reviews. Anybody ever heard of this one before? Okay, so this is a code review. I won't talk about too much. I want to get to other stuff, but go ahead and click on this link in the notes and check it out. But it essentially allows you to review people's code in a larger project, vote on it, say I gave it a +1 or I give it a -1. There's also +2s and -2s. -2s mean this code will not ever get into a repository. A +2 takes that. It's essentially a pull request, but it's a little bit different in how it works. And if you give it a +2, it takes that bit of code and it merges it. And so the Android SDK, like the open source version of the Android SDK, uses Garrett to do code reviews. So any one of us can download the source code for the Android SDK. If we find a bug or we want to make an enhancement, we can write that code, push it up to Garrett, and then the Android SDK team, most of them work at Google, will review your code and say, yeah, this is a feature that we want, and accept it. They'll vote on it. They'll discuss it. It has a whole bunch of, kind of like a forum for that commit. So it's a lot more powerful than pull requests if you're used to that on GitHub. If you have no idea what I'm talking about, don't worry. It's just, it's a really cool tool that I used many years ago, like 2 or 3 years ago. Okay, so the topics that we're going to talk about today, if you are interested in any one of these, accelerometer, light sensor, built-in camera, services. These are background services or just services in general. And we'll talk about what services are specifically. Audio, so if you want to play any music or any audio, voice audio that could be. Or if you want to implement your own custom views. So this is going to pertain to your final. These have nothing to do with any of the projects that we're going to do in this class. That's kind of why I'm going to lump them all in this one presentation and then throw them at you. And if you're interested in any of them, hopefully they stick and you can research more into them. And then there's also web views, location services, content providers, and advanced maps. So this is advanced features of the Google Maps fragment that we're going to talk about and how to draw lines and things like that. which again you don't need for project 2. But so this is the accelerometer code. This is pretty much, let me see, yeah, there's a couple other ones in there. So like any hardware feature that we need to get in Android, the first line of code here, we get system service. So if you remember I do believe the camera for, what was it? Oh, the location manager. Excuse me, I was thinking of something else. The location manager, to get the GPS coordinates, called get system service, but we passed in a different constant. This one we're passing in the sensor underscore service, and then that's going to pass back a sensor manager object, and we're going to assign that to the sensor. This formatting got all messed up. This is supposed to be in the onCreate method and assigned to a member variable called sensor manager. I don't know why it's all on one line essentially, but that's how you get it. And then from that sensor manager, you can get the accelerometer, and it's called by get default sensor, and then you pass in from the sensor class another constant type accelerometer. So you see me do this kind of pattern in class where I define a constant, but I declare that constant in a class. This is how Android and most Java programmers do it, but you might say, well, why do I have to do all this stuff to do the accelerometer? Can't I just call, accelerometer service here? Well, there are other sensors on your device. There's sometimes a barometer, actually, or a temperature gauge. There's also a light sensor, that sort of thing. So this is how to get all those things. I'm just showing you accelerometer because that's probably the most interesting. But to get those other services or those other sensors, you use the same get system service, and then within that you get the specific sensors. Okay, so then in my on resume, and again, I don't know, sorry that this is all in one line. We have msensormanager.registerListener. And so what you're going to do is you're going to give it a method, and you're going to say, I want to call the, I'm going to send it this class in order to get updates on the accelerometer. And how often do I want to get those updates? Sensor delay normal. There's different constants in there. You don't specifically say I want it every 100 milliseconds or I want it every second. You have these constants in here, and whether that changes on the device or changes between operating systems or versions of operating system, you don't really care. That's why we use constants. We just leave it up to the Android SDK to define those. So delay normal, I don't know what that means. Maybe that's 60 times per second, 30 times per second, or 30 hertz is another way you might see accelerometer. The delay is what they're calling it here. But anyway, the next line is in my onPause method, I do msensormanager.unregisterListener because in the onPause, that means something else is on top of it, or my app is going to be put into the background, that sort of thing. So we don't want to keep continuously using the accelerometer because it uses the battery, and you can leave it on if you need it, but usually you do that in the onPause to turn it off. So unregisterListener, this will turn it off. And then finally, we have the final two methods. On accuracy changed, it'll tell you, hey, something's going on with the accuracy of the sensor, but also the accuracy of the accelerometer specifically. And then finally, on sensor changed is the, I do believe that's the callback that you implement for getting those events. So for example, when I tilt my phone to the left, you'll get an X, Y, and Z coordinate system of where it is in space. And then also, because it's called an accelerometer, you get the acceleration. So you can test if I throw it up or I take it on a roller coaster, for example. You can get all those sensor readings. How many G's am I pulling? How many times gravity am I experiencing? That sort of thing. So it could be a fun science project to get the accelerometer data, save it into an array, save it out, graph it, that sort of thing. So pretty cool stuff, just with your phone. So some of the, I didn't have it here, but some of the, what's it going to be? So you can actually simulate different gravity. And so the different gravity constants, obviously it's 9.8 meters per second is the Earth's gravity, but we also have these other constants. Gravity on the Death Star, this is the first Death Star, mind you. Of course, this is just an estimate because nobody actually knows. And these are real constants in the Android SDK. I didn't just make these up. But so these are also in Empire units, whatever that means. If we have any Uber Star Wars fans, maybe you know how to convert Empire units to metric or whatever. We have sensor delay fastest. So I did illustrate the sensor delay normal. This is just the default rate for screen orientation changes. What that means, I don't know. Maybe that's a half a second. Maybe that's a second. That's what Google has determined that's suitable for screen orientation. This comes from the all this comes from the documentation, by the way. We can go down here in the sensor manager. I'll show you that in a second. We also have the fastest delay, and so this is as fast as we can get. So maybe if you're doing some kind of science project where you're on a roller coaster, or you want to send it on a merry-go-round or something, and you want 1,000 points per second or whatever your device can handle, use sensor delay fastest. You put that in as the sensor manager register listener. And then there's one suitable for games. So it's not the fastest because, again, we want to try to get the lowest rate possible but still be responsive enough. So for games, maybe you're doing a race car application or game where you're tilting the phone as the steering wheel. You'd probably use that one for that. You wouldn't want to use fastest because you probably don't need that granularity of accuracy for, let's say it's 1,000,000 times per second. You really only need it maybe 100 times a second or even less than that. And then finally, the sensor delay UI is the rate suitable for a user interface. So not orientation. What this might mean is maybe a second, 2 seconds, that sort of thing. I don't know what they actually are. You could probably spit those out and see what they are. Maybe they're just like 1 and 2 and 3. They're not actually rates. But let me show you the documentation in case you want to look more into this. And all the slides, all these topics have links back to the documentation. So there's the code basically that I have in the notes. When you get the sensor event, you have the axis, so X, Y, Z axis. You also have these constants here. So there's gravity on the Death Star 1. Let's see if I can make this slightly smaller. We have gravity on Earth, gravity on Jupiter, Mars, all the 8 planets. 8 planets, and except for planet 9, if you guys haven't heard, is something like 3 times farther out than Neptune, I believe. So that's a new planet, potentially. We don't have that gravity yet because we don't even know anything about it. We have gravity on the island. We have any Lost fans here? Fans of the TV show Lost? Apparently that had its own gravitational, yeah, whatever, because I guess that's what brought the plane down in the first place. Yeah, so a lot of really fun things. Here's ones for the light sensor. So you can simulate or get the light sensor on a cloudy day, on a full moon, no moon, overcast, shade, all these different values in here. We also have the internal magnet, or the internal compass, I should say. And so we have the magnetic field for the Earth, the max and min values for those, and a whole bunch of other sensor constants that you can look through. Some of these are pretty funny, as I mentioned, the Death Star and that sort of thing. I don't know why they don't have the Death Star too. But anyway.
I do an activity with my physics students where you can actually take we do it on Tatooine.
Okay.
You can actually, there's a scene where something gets dropped, but they happen to have the acceleration of gravity happens to be 9.8 there also.
That's interesting.
Because it was filmed on. But I still wonder if
I know.
where they got the Death Star's gravity from, if like things in the movie are different rates.
Yeah, just based on the density of it and the size, and yeah. I mean, somebody figured it out. Somebody spent the time to figure all those calculations out, but I don't know if that's on the surface of the Death Star or within the internal structure. So that's another question. I guess you have to program that in there. Like if you're on the 100th floor. Yeah, because theoretically in the center of it, it would be weightless. Anyway, I'll move on with this. But these are more constants and more documentation than you probably would ever want to know on the sensors. What I was looking for, though, was the sensor constant. So let's see, what am I looking for? Just looking for a list of all the types you can get, because this is kind of interesting. Okay, type pressure. I don't know if that is a light. You can get the altitude, so this is based on the barometer that your device may or may not have, so it really depends. And you can just do a quick if statement to see if this sensor comes back as null, or it actually comes back with a sensor manager for that particular sensor. Yeah, somewhere in here they list all the... There's a proximity sensor. Okay, well, I won't spend too much time with that. Okay, next is the camera. So you say, oh, we already talked about the camera. Well, we talked about the camera activity. So launching a full activity to take up the entire screen. But what happens if you just want to take a photo with the camera? You don't want to have this entire user interface pop up with a viewfinder and a button. Or better yet, maybe you wanted to customize that UI with your own. So last time we talked about Polaroid. There's another type of camera called a pinhole camera, and the idea behind a pinhole camera is it's a box. You put a pinhole at one end and a piece of film on the back, and what you do is you uncover the pinhole for a set number of seconds to expose the film, and then you cover it up either with your finger or a piece of paper or whatever. Very, very low tech, but they actually have mobile apps, Android and iOS, that simulate that exact thing called a pinhole camera. So if you search the App Store for pinhole camera, you'll see this. And the nice thing about the pinhole, or I should say the unique thing about it, is it doesn't have a viewfinder. Again, it's a cardboard box, and you just point it at whatever you're trying to take a photo of. You uncover it, and then for a set number of time. And it's just for camera enthusiasts. But you can implement that same exact thing because you don't need a viewport here. And the way that we do that is, again, we ask the SDK or the operating system, we need the permission to use the camera. So that goes in the Android manifest file. To get the camera itself, to get a reference to it, we have to get the number of cameras. And so most devices these days have two cameras, one on the front, one on the back. So we have to loop through them. We get the number of cameras, and then we have to loop through all the cameras. So get camera with the camera info object, and then we can ask it which direction are you facing. And if it's facing the front-facing camera, again, this is a constant that's declared in the camera info class, then set our camera ID to this index, and then what we do is we get the camera ID from the camera class. And so this is what's referred to as the camera API. So if you ever want to do your own custom camera stuff, this is one of the easiest ways. You can also get a reference, or not a reference, but a video stream, I guess I'd refer to it as, what the camera's seeing. So this could be for image recognition. So this is how barcode readers work. So if you want to have some kind of UPC or barcode or QR code, who's ever scanned a QR code in their life? Oh, okay, wow, almost everybody. I think I asked that like a year or two ago. Nobody. Most people didn't even know what a QR code is, but it seems like most people are. I won't say getting with the times, but yeah. So that's how those libraries work. You can download open source libraries to scan QR codes within your application, and this is how it does it. It gets a reference to the camera, and then it just reads in that image data. There's a slightly different API. This one's called Take Picture, which will pass back a I forget the type, but I want to say a bitmap of what the camera is currently seeing. So you just make these calls, and that's how you get very, very fine-grained control over the camera. So I thought I'd just throw that out there. Also, when you're doing when you're passing in this Photohandler to handle the actions of the camera, you pass in the application context. This is essentially a reference to your application, so that when the Photohandler does its thing, it knows it knows all about your application. So that's how that happens. This is the type of thing that we try to avoid in application programming, is passing around all these references to these things. In iOS, the application object itself is a singleton. You can get it from anywhere, so it's just a little bit different. Android's a lot older code base than iOS is, or as iOS is intended. It's based on the Mac OS X kernel, but the actual implementation of iOS is a lot newer than Android, which dates back to the early 2000s when they were still doing flip phone type mobile apps. Okay, so the photo callback that you get in the Photohandler, these are the methods that you override. So on picture taken. I guess it's just byte data. Okay, sorry, I thought it was a bitmap, but it's just byte data. And then you also get a reference to the camera, so you can query whether that was the front-facing camera, the rear-facing camera, if for some reason you had to set it up differently. But that's why they pass in the camera as well. So, yep, that's all you have to do is just get a reference to it, take a photo, and then you'll get the callback in this handler. Okay, so in the background services, we're going to talk about background services, but background services allow you to do things in the background. So any kind of service, whether that's playing music or maybe uploading stuff to a server constantly. So let's say you have a running app, you're a fitness app, you're jogging, and every 5 seconds, every 2 seconds, you want to upload data. You want to grab that GPS location and then upload a object, a JSON object or whatever, to some server out in cyberspace somewhere. You would do that with a background service. So you would set the background service up using an intent. So initially you create this, let's see, what's this code? This is I just looked at this before class, so sorry. Okay, this is not the specific one. I've named this differently, but let's just say you want to do what I was saying with the login application. Ignore the variable names. This is for a message, like a background messaging thing. So we create a new intent, just like we do with any activity. We pass it the context this, but what we do instead of passing it a reference to the activity class, we're passing it a reference to this class that we have declared called simple intent service, which is defined up here called, oh wait, hold on. It should be this guy here. Let me see what the, okay, I'm sorry, I messed these names up. So this one is actually supposed to be this one up here, which extends the intent service. So it's not an activity that we're launching, we're actually launching a service. So this is another example of an explicit intent, but this one is just essentially going to run this class in the background continuously. We have some service keys here that we're actually passing in values for. So for example, we have the simple intent service. Again, that's supposed to be called custom intent service. And then param and message, string input message here. I think I messed these values up. But anyway, we're doing what we did with the camera or any other activity intent, is we're passing in a value to our intent into its extras bundle. We're starting the service, so instead of start activity or start activity for a result, we're calling start service. We're passing in that intent, and then once that intent gets launched, this code here gets called. So our constructor gets called here, but then we have this on handle intent, and here we can actually pull out that value from our extras bundle and do something with it. So maybe it's a song name, and it'll go off and pull that out of the extras bundle and then go ahead and play that song. It could be a command. If it's a GPS running application, you might not pass anything in, but instead this on-handle event might go and grab the GPS and set up maybe some kind of threading to do something like maybe just an infinite loop kind of thing, because it's on its own thread, so it can do whatever you want. So yeah, that's how you do things basically in the background. So it's pretty simple to do. The next thing we have is broadcast intents. So this is where event bus or auto, I have slides on there. This is the third one that I mentioned that you probably don't want to use because the other two are a lot better. But how do we communicate between classes without passing references back and forth between classes? Well, we use broadcast events for the observer pattern, sometimes referred to as the broadcast pattern as well. But we create a new intent, just like we do with all the other the implicit intents, like the camera stuff. The broadcast intent.set action is going to be the actual action that you are going to be broadcasting. You can put it into a category if you want, so that just the default category here. So this kind of allows you to organize your messages between classes and objects within your application. We can put extra data in there, so if you want to pass around, for example, if we're adding a pin to a map, we might put the pin in, or the GPS location as a string here with some key, put that in the extras bundle for the intent, for this broadcast intent. And then again, instead of start activity or start service, we do send broadcast, and it takes this object and basically throws it up into your application, and who's ever listening to it will get this intent. And the way that they get the intent is you have to implement this class that extends broadcast receiver and receive that broadcast and yada yada yada. So it's not as nice as, again, just saying, hey, get the event bus singleton, post an event to it, and then I'm going to have a method that gets called in there. You got to do a little bit more setup here. And I'm not even sure how the threading works on this. I don't think it comes back on the UI thread, so you'd have to handle that as well. But I could be wrong about that. I just never used it before. So audio playback. How do you play music back? So maybe you want to do this in the background service that we just talked about. You create a media player object, instantiate that with the new media player constructor, and then that's pretty much it. But we have all these commented out ones. You can call .start on it, .pause. Oh, sorry, you have to set the data source to whatever the path to the audio file is. So the path to the audio file, if you have this embedded in your Android device, you can load it up locally, just the same way that we did with the camera image file URI. This would be a slightly different path to it, but you can load it up that way, or you can just pass in a URL on the internet somewhere if you have that stored there. So pretty simple stuff. Here's the documentation for it, and that's pretty much all you need to know, except for the fact that you should play these in the background unless it's just a quick chime or a buzz or a beep. Then then you don't need a background service for that. I know I'm moving through this quickly, so if you have any questions, just shout them out or raise your hand. Web views. So we are in Android, have the ability to implement an entire web browser within an activity. So we have a web view object, and if you're in the interface builder, you can drag this onto your UI and resize it all you want, but here's the XML for it. The only thing that we have to do is call web view, and if you remember to do a text view, it's just text view, or an edit view, or that sort of thing. So this one's just called web view, and it pretty much has the same format. So we give it an ID. In this case, it's web view. We have a layout width, which is to fill the parent, and we have a layout height, which is to fill the height and the width. So this will take up the full activity. So that's all you need to do for implementing a web view. And then later in our code, maybe in our main activity code, in our onCreate, we get a reference to it, find view by ID like normal, r.id.webview, because this web view here matches, again, the ID here. So now we have a reference to it. And once we have a reference to it, all we have to do is call .load URL and pass it whatever URL you want, and it'll handle it for you. Now, to do things like navigating back and forward and that sort of thing, there are method calls on this class, on the MyWebView instance, that you can call in order to handle that functionality. But it's all there in the documentation, but that's basically how you do it. You can also get callbacks when the page changed. So if somebody clicks on a link within the page, you can get a callback to see what the URL is and maybe either allow it or disallow it. So one instance might be having a child-safe web browser where you only give them one site to be on, right? Go to Disney.com, and if you try to navigate off the website, the app won't let you do it because it'll look at the domain, and if the domain is not Disney.com, then it doesn't allow you to do it. Or you can have a list of child-friendly sites in there that they can only go to, and maybe a nice UI that they can pick between the two sites. Maybe there are your own website properties that a child can choose from, or even an adult if it's for some other purpose. So it's really, really, really powerful. And yeah. And actually with, I want to say almost 0 lines of code, you can implement a web browser. That's not exactly true because you have to put in the Android permission.internet to ask for access to the internet. And then you have to drag in this guy, which isn't technically typing in code. And then you can fill out its, yeah, I don't know if it has a source field that you can pre-populate that with a URL. But anyway, maybe you write 1 line of code or 2 lines of code, and you can get that working. So pretty easy to do. So in case your application wants to display a website, then there's that. Now the custom views, if you guys want to do your own custom view for whatever reason, maybe you want to implement some kind of graphing, you know, having graphs and rectangles and pie charts and that sort of thing, you can use a custom view. Or if you want to display some really cool graphics and then animate that by having them slide in and that sort of thing, you can use custom views. And the way the custom views work is you simply create a Java class, you extend the Android view class, and then, you implement it, or you subclass the view class, and then you override the onDraw, onMeasure, and onKeyDown methods. I think those are the only required ones that you have to override. The onDraw is a looped method that gets called however many frames per second that the view gets redrawn. So it could be 60 times a second, it could be 30 times a second, depending upon what your device is capable of. And this is where you can do your animations. This is where you can put stuff on the screen. You might do it over a course of a period of time. So for example, if you want to animate a square from left to right, you would essentially just keep redrawing that square over the x-coordinate system over a period of time. So it's a little bit more complicated than just saying I'm going to move it from x to z, but there are methods in there that you can do that. Question?
Yeah, it may be unrelated, but I was curious. I was trying to listen to all the different things there. I read some mom developed, I believe it was an Android app, I don't know, but anyhow, it was an app that she put on their children's smartphones. That basically, if they didn't respond to her call or something, it shut down their phone. And
Okay.
so it listened and made sure that, okay, I don't know exactly, there's obviously some built-in security features so it can be disabled or uninstalled or something. But I was curious as to what would allow that to happen.
Okay, so specifically, so the question was,
I mean, how would that happen?
how do you, let's say you get a phone call from a certain phone number and it's not answered.
Yeah, say like it's not answered.
After 10 minutes, if you don't call it back, it shuts down your phone, right?
Right, and then the only thing you can open up is like she's able to open up for the sole purposes of calling that number, or maybe like 911 or something, but that was it.
Yeah, so I can't speak specifically to that feature, but you can query the Android operating system and have it do basically anything that it can do. You can have it do. So you can have it shut off the phone. You can have it monitor who is calling you. So the one cool application that I saw that kind of mimics that is not being able to send or receive text messages if your GPS data is telling the phone that it's going over, say, 20 miles an hour. So the GPS data that you get is not only latitude, longitude, it's also time, it's also altitude, and it's also speed. So it'll actually calculate your speed for you. So the application can monitor that and say, okay, he or she is driving over 20 miles an hour. My GPS is saying they're driving over 20 miles an hour for, let's say, more than 10 seconds, because maybe the GPS, if you've ever tracked GPS, sometimes it'll say you're in one point and then throw you across campus the next half a second, which now you're going faster than the speed of sound, but that's just that's just your GPS working or not working. So you have some kind of calculation in there to say, okay, if it's longer than 20 seconds, tell the operating system to turn off SMS or text messaging, or even turn off the cellular receiver so that you can't make phone calls, you can't send phone calls, that sort of thing as well. I don't know specifically how to do that. I could look it up in the documentation and see what specifically you need to call in the operating system. And it's something very similar to the services call, I imagine. I could be wrong on this, but to get the accelerometer would be very similar to probably how you tell it to turn off Bluetooth, how you tell it to turn off the cellular signal, that sort of thing.
I just thought that's a great idea, especially, if you could say, hey, you're not answering your phone, because it drives me crazy when my kids don't answer their phone.
Absolutely.
After a while, right?
Yep.
And then, they'll get a text back to you quicker. But it's like, hey, I'm taking control of your device. This is not your device. It's my device.
So they can only do a voice
It's
call.
my device. I pay for it. You can't privilege it. You block the privilege.
Yep.
Boom. Done.
Yep. Absolutely.
I like that idea.
Yeah, you can't actually do that kind of thing on iOS, and it's because it's a different environment where Apple doesn't want to give developers the power to shut people's phones off and that sort of thing. So it is very intrusive, but yeah, if it's your phone, this is kind of the Android way, is if it's my phone, I should be able to do whatever I want with it. And there are ways to do it in iOS, you just can't have those applications on the App Store, right? So you can develop them for yourself and not even jailbreaking your phone, but just accessing what's called private APIs, which you might have to do in Android. I'm not exactly sure how to do some of those things, but I know for a fact that like turning off Bluetooth is a simple 1 or 2 lines of code, maybe a few more, but you get the service and then you just tell it to turn off. And that's really nice because if you have an application that requires Bluetooth to work, like if it's a peer-to-peer game, like a card game where you need to interface with somebody else, you can turn on the Bluetooth for the user rather than having them, going to settings or slide the, there's a menu in the top right-hand corner that you can slide down to turn Bluetooth on. But you don't want Bluetooth on all the time because it eats your battery. So if developers are turning on my Bluetooth, I might get a little annoyed. So it's a very fine balance between how it works. And Apple's locked it down so much to try to increase the enjoyability of the phones for most people. But people that like to hack on their hardware and do things like shutting down cell service when you're going 20 miles an hour or something like that, yeah, that's Android. So when you're talking to clients, if you're doing consultations or you're doing an app for them, and they're like, oh, I want to do this and this and this and this, and I want it on iOS and Android, you'd be like, okay, well, that's great. You can do that on Android. You might not be able to do it on iOS, or even vice versa. There's obviously give and takes on both, advantages and disadvantages on both. But yeah, that's a great question about what you can do in Android, and that's essentially almost anything. To an extent, Google's also started cracking down on some of these things as well, because they realize when they give developers almost unlimited freedom with people's devices, they take advantage of it. So, yeah, Apple realized that early on and said, nope, we're only going to allow you to do this much. And then over the years, they've kind of eased the requirements and the restrictions so that you can do more. And it's kind of funny because it's like, oh, Apple introduces this new ability to do background services. This was like, I think in iOS 4. Now you can run tasks in the background even when your app is closed. And all the Android users or developers are like, we've been doing that for years and that sort of thing. They've been doing it for years, but very poorly, in my opinion, which is why Android back in the days had terrible, terrible battery performance, where iOS and iPhone was awesome compared to Android at the day. I mean, you get 12 hours on iPhone back in the day, but the Android, you'd have to plug it in every 4 hours. Now everything's pretty much level-ish. It depends on the apps. Like Facebook, for example, sucks down your battery power both on Android and iOS. So it doesn't matter what platform you're on. It depends on the apps that you're using. But yeah, good question. Anything else? Right. Yeah, just raise your hand or shout out as we go through these if you have deeper questions on these. Okay, so we talked about custom views. If you want to do 3D, so instead of just moving around squares and circles or whatever you want to draw on there, you can draw paths, of course. You can do 3D. So this instead is extending the surface view, not the view class, but the surface view. And then this all happens the drawing happens in a separate thread, and we can use OpenGL for our custom views. If you have a 3D model, I haven't tested this on Android, I've done it with iOS, but if you have a 3D model, you can put that in. And so I ran through this 3D tutorial on how to make a TIE fighter, and so I threw that into an iOS app and it worked wonderfully well. You can do the same thing here on Android, so if you want to download a free 3D model, because they got, just search 3D model on, or free 3D model on Google, and you can download these files and then incorporate them into your application. Obviously, you have to check the licensing on them, but for example, if you want a nice 3D lamp or something that's rotating in your application or that turns on, this would be a great implementation on how to do that. And you don't have to know anything about modeling. You just have to know how to load those models. So it's a pretty powerful tool. Again, we can do full 3D in Android. It's pretty much a full computer. So a lot of the games you might have seen they probably implement something similar to this, but they do use OpenGL for a lot of those things. Unity 3D, or Unity, the game engine, uses some OpenGL for Android. If you're going to use I believe this pertains only to the surface view for 3D, but you have to override the onMeasure method and pass back the calculated method. So this is kind of a couple extra steps that you have to do in order to figure out what your view actually is on the device. So whether it's rotated in portrait or landscape mode, you have to set that up. You have to do the calculations, and then finally you have to do set measured dimensions. You have to pass it in height and width. If you don't do that, then an exception's thrown. So just to put that out there, that you do have to set that specific set measured dimensions, because you might try to follow some tutorial online and realize, why is my application crashing? It's because you haven't set the measured dimensions of your view. But that's just there, in case you do want to implement that. All right, so how do we actually draw stuff on the screen? Well, here are just two methods. You can draw a rectangle and then pass it a height, width, and X and Y coordinate. The draw path allows us to put in a whole bunch of different points and draw lines connecting A, B, C, and D. So for example, if you want to draw a basic shape, you literally have to put in the X, Y, Z coordinates of that, and then put that into draw path, and it'll draw a path. You have to set a stroke and a stroke width, a stroke color to get the color of that path, yada yada yada. So it's a bunch of code to do this drawing, but if you want more information, then you can look up this documentation there, but I won't talk too much about it, except for when we talk about drawing on Google Maps, which I'll talk about here in a second. So for one example here, we can set the padding of the Google Map, which, just adds padding to your map that you... I don't even know why I have that in there specifically, but it's just one of those things. But if you want to draw specific lines, let's say we want to outline Ada County, what we'd have to do is figure out all the dimensions, not to every meter, but we can get the rough outline of the GPS locations that define Ada County. So right now this is just drawing a box. These numbers look the same, but they're slightly different. And so this is just drawing a box around this particular point. It's putting all that into a polyline options object, assigning that to the rect options variable, and then using that rect options variable in the last line here to add that polyline to my map. This is different from a polygon, which is a closed shape. So if you wanted to do the outline of Ada County, you can also do fill color too. This is just an outline, but if you want to do fill color, that's you can add that parameter in the options as well. But if you want to do Ada County, you would do a polygon because that's closed, and then you can set a fill color of maybe, let's say, like a light gray that's slightly transparent, so it has a nice kind of fill on that to show Ada County. Maybe you outline Canyon County, make that some other color and that sort of thing. And then allow the user to display that in Google Maps, and then when you zoom in and out, those stay in those specific points. So this is a really cool, powerful way of not only doing that, but also if you want to map your runs too. So you take the GPS locations and you just put those GPS locations in that. And I will say that when you do that, you have to actually add the polyline to the polyline and then re-add that to the map. So you can't just add one pin or one point to the map. You have to actually recreate it. Okay, so this is the polygon. So it's not much. It looks almost exactly the same. It's just a different class, but it'll connect the last point to the first point. Map strokes. So I talked about actually having to color and do the thickness of it. So we can get the stroke color. We can set the stroke color, and we use a constant color.green. Or we can do Android color, so Android.R. This is our Android R class, but instead of doing .id or .layout, we do .color, and that'll give us a bunch of constants that's defined in our Android SDK. And the Holo Blue Dark is a theme color for the Android operating system. I forget which one it is. I want to say it's, I don't know, let's just say 4.0, 4.1. The operating system itself has a theme, which I think is dark blue, black, that sort of thing. So you can get those exact colors via this way. So you can define all sorts of different ones. And then if you're more of a designer, you can get the hexadecimal value of this. And so this is RGB value. So I do believe that's just red, full red. It's RGB-A, actually. So it's alpha as well. And actually, let's see, is the alpha first? I forget what order these are in. The alpha is the transparency. So if you want to make it slightly transparent, there's two values for that, and then RGB has two values, two hexadecimal values for that as well. If you've done anything with web and colors, you probably know what those are. The fill color, and we can set this to transparent. So that just means obviously you don't see any fill color, but if you set it to red, you set the alpha on that to, let's say, 10% opacity, then you get this nice red tint to your fill color. We also have the stroke width. So the stroke, when I draw these paths along, let's say Ada County, I can make that 10 pixels, 5 pixels, 20 pixels, and it does not scale when the map is zoomed. So for example, if I zoom in on the border, it's always going to be 10 pixels. If I zoom out, it's always going to be 10 pixels. If I zoom out so I can see all of the United States, what I'm basically going to get is a black or red, whatever color you have it, box. So again, it doesn't scale. It always stays 10 pixels. Just you'll see that. And then we have a z-index of where these items lay, so you can put paths on paths, shapes on top of shapes, and we use the z-index to define which one goes on top. We can set these visible or invisible, so we want to turn them on or that sort of thing. So for the map UI, I do believe I talked about this in the example code for the maps. I think I listed some of these. Here's not a complete list, obviously, but it's a pretty useful complete list. Set zoom controls enabled, so these are true or false values. This is giving you the ability to tap a button to zoom in and out. The compass will show you what your orientation is, so it'll say, north is over here, that sort of thing. You get a little tiny compass. Set my location button enabled. This will put a little blue button, I think in the top right. It actually depends on the OS version. If you tap on that, it'll center the Google Map on your location if your app has asked for the GPS location of the user. The permission, that is, not code. It'll do this automatically. Set zoom gesture enabled, so if I pinch and zoom, or if I pinch or expand, that'll zoom. I think that's on by default. Scroll gesture enabled, so if I'm moving my finger around, whether that allows the user to scroll. So if you want to do, like, I want to show a map of this particular business's office, but I don't want the user to scroll around, you would disable that particular feature. You'd also disable the tilt gesture and maybe even the rotate gesture as well. The rotate gesture allows you to move the map by using 2 fingers and twisting them. The tilt one, I forget how to actually do that. You've probably done it by mistake. I think you hold 1 finger still and move the other one, and it'll actually tilt the map. And Google Maps is really cool where they'll show you mountain ranges, and in some larger cities, it'll show you the landscape of the buildings in 3D. So it's really, really cool. But if you don't want that feature turned on, you can turn it off. For gestures, what if I want to listen to when the user's scrolling the map? Well, we have a click listener. Oh, I'm sorry, yeah, this is a click listener. If they tap on the map, we can get a click listener for that and then get a GPS location of where they tapped and that sort of thing. And then there's also a long click listener. So what happens if I tap on the screen and I hold it down there? You'll get the on map long click listener callback here. And these work exactly the same way as your regular on click listeners. So I don't have the code in here, but that's how they work. And then finally we have the set on camera change listener. This is the one where you scroll the map. You can get a callback in our change listener where that is, where the camera's pointing, how far zoomed out it is. So you can manipulate it that way. There was a web-based Google Maps game that played off of the Monopoly game. And so here in Boise, you could buy property. You could buy Broadway Avenue, put your properties right on Broadway, put your property right on like actual places within Google Maps. And they just used the Google Map API to allow them to do that. And so it was networked, so everybody here in Boise or anybody that was playing the game that was local, they could buy real estate and that sort of thing. And so you'd see other users and their properties on there. So if you got into the game early, you could buy real estate. And it was just a really fun use of the Google API. And so maybe you can do that with your Android applications as well. But here's all the documentation for the camera position stuff. I do believe that also has the ability to manually position the camera. Okay, let's talk about geofencing. I don't have a lot in the notes because everything that you probably want to know is in the documentation. They do a pretty good job of explaining what it is, but also how it works. So in this particular example, they set up a geofence located at that bus stop here, so California Ave, Caltrain Station, and they've put a perimeter, let's say it's, I don't know, it looks like 50 meters, 100 meters, and the green line that shows you entering that geofenced area, you'll get a notification that, or a callback in code that says, okay, this user has entered this location. So I guess, I haven't read this, but I guess this is for the train station. If you have the train station application on your phone, it registers the geofence in all the different train station locations that it has. And when you walk within a certain perimeter of that station, it can pop it up. It can show you the train times for that particular station. You can say, okay, the next train's leaving in 5 minutes, hurry up, or the next train doesn't leave. Or you can even say things like, the next train leaves in a half hour, but we close at 7 o'clock at night or something like that. So really, really powerful, almost self-aware applications that you can program to not only know the GPS location of the user, but get notified of when these users go into these locations without having to pull or monitor the GPS location yourself, because that's very, very expensive battery-wise for these things to do, because you're constantly saying, okay, GPS location, am I within the train station? Allow the operating system to do that, because the operating system is basically grabbing these GPS locations anyway. And then finally, when you exit the perimeter, you get a notification for that as well. So pretty cool stuff.
How accurate is that perimeter?
You set the, we can look at how it's implemented. So you have to ask for the permission for the GPS, of course. Yeah, this is it. So we create the service for the GPS or the geofence stuff. We add a circular region here, and we just set the latitude and longitude, and then the radius.
And so it has to be a circle.
Yeah. No, it can be. So this is just circular region. It can be.
Rectangular region.
Yeah, it can be a polygon. So for example, using Ada County as an odd-shaped, not a square, not a circle, you pass it in a whole bunch of latitude and longitudinal objects to define where that geofence is. Yeah, so you're not. I don't think you're limited to. I'm pretty sure you can do this with multiple points. Yeah, I just don't remember exactly how that works with multiple points. So again, that's geofencing. You can use it for if you get home to pop up your reminders application. Say, take out the trash, feed the dog, that sort of thing. When I get home, so you tell it where you live, and you can set a geofence on that. Okay, so because we're on mobile, we kind of take advantage that we have network capability. We have the internet accessible. But what if they're on a tablet that doesn't have cellular data? A lot of tablets do have cellular data, of course, but not a lot of them do. So how do we ask that, hey, do we have network connectivity? So this is a few lines of code to ask the operating system, hey, can you connect to the internet right now? So you get a connectivity manager. We call get system service. So you should be seeing a theme here. We pass in the context dot connectivity service. That'll pass back a connectivity manager. And then we query the connectivity manager to get the network info. And this will tell us a lot of things, whether we're on Wi-Fi, whether we're on cellular, a whole bunch of stuff. But more importantly, am I connecting or connected? And if it is, then say, okay, you're fine, run whatever command I want. Or no, I'm not connected. Maybe pop up a message letting the user know, hey, I need to be connected in order to work. So a few lines of code is pretty simple. And that is all the slides we have for today. So we got a few minutes left in class.